In this video, we're going to discuss factoring binomials. These are polynomials with only two terms, and there's going to be some special ones that we look at especially. The first one that we're going to look at is the difference of squares. The difference of squares is where we have two items that are squared and we're subtracting them. So for instance, if I have x squared minus 16. Now let's think about what that actually means. X squared minus 16, if I come over to the side, that's the same thing as if I were to say x squared plus a 0x minus 16. Because remember, previously we discussed the ax plus bx plus c form. And so what we're actually trying to do is find factors that multiply to give me negative 16 that add to give me 0. And that's what we're looking at when we're talking about difference of squares. For the squares, we're talking about things that are perfect squares, such as 1, 4, 9, 16, 25, 36. Notice the numbers that I just rattled off are the ones that are 1 times 1, which is 1. 2 times 2, that's 4. 3 times 3, that's 9. So I can take the square root of that number, or it's the same number multiplied by itself. So if I think about 16, that is 4 times 4. And x squared is x times x. So notice I've got 2 x's and 2 4's. So what's going to happen whenever we factor these, and it's very important to notice that it's a subtraction here, we're going to have 2 blanks, and the first x is going to go in the first blank, and the second x is going to go in the first blank. So the first variable gets split up into the first blanks, and the second number here, the 4's, get split up and go into the last blanks. So 4 and 4. And then what happens with my signs is that I'm going to have one negative and one positive. So I'm going to have a negative and a positive. And in this case, it does not matter what order I put it in. But notice that if I were to come over to this side over here and think about numbers that multiply to give me a negative 16, that add to give me 0, what we're looking at is a negative 4 and a positive 4. Those would multiply to give me a negative 16 and add to give me 0. So notice that's what I have here, a negative 4 and a positive 4. So whenever we're talking about difference of squares, we're going to split up the two numbers in our binomial into what times itself will give us that item. Let's look at another example. If I have m squared minus 49. Well, m squared can be rewritten as m times m. 49 can be rewritten as 7 times 7. So whenever I go to factor this, I'm going to have an m in my first blank because that's my first item, and I'm going to have a 7 in my last blank, and then I'm going to have one negative and one positive. And I can always check myself by foiling these back together, because I can get m times m, which gives me m squared. M times a positive 7 gives me positive 7m. Negative 7 times m gives me a negative 7m. And a negative 7 times a positive 7 gives me a negative 49. When I combine like terms, these two, positive 7m and a negative 7m, actually cancel out, leaving me with m squared minus 49. So I do get what I started with when I multiply these back together. So I have my factored form. It is very important that it is a subtraction, because if I were to have an addition, such as y squared plus 25, well, our first instinct is to say, okay, that's a y and a y, a 5 and a 5. I can do y 5, y and a 5. And if I do let's do that again, y and a 5, a y and a 5, and a subtraction and an addition. But if I were to FOIL this back together, we have a little bit of a trouble, because y times y gives me y squared. Y times a positive 5 gives me positive 5y. Negative 5 times y gives me a negative 5y. And a negative 5 times a positive 5 gives me a negative 25. So that would actually give me y squared minus 25. This is not the same as what I got, or what I started with. So I've got something wrong here. So let's get rid of this, because that's not going to work. And I could try different combinations of my signs, but let me come over to the side and look at it this way. Y squared plus a 0y plus 25. I want to multiply to get me a positive 25, and I want to add to get me 0. Well, the factors of 25 are a positive 1 and positive 25, negative 1 and negative 25, or a positive 5 and a positive 5, or a negative 5 and negative 5. Because remember, I want it to add to give me a positive 25, so I have to make sure that they have the same sign. Now when I add these together, that gives me positive 26, or a negative 26, a positive 10, or a negative 10. None of these combinations actually add together to give me 0. So whenever I have a square plus a square, this one is prime. We cannot factor it. If there was a greatest common factor, yes, we could factor out the greatest common factor. But if there's not, we have to leave it. Let's look at some other examples with the squares. And let's look at 4a squared minus 9. Okay, first let's see, is there a greatest common factor I can factor out? Which, no, there's not, because I can't take a number and divide it into 4 and 9 evenly. And there's not an a in both of these. So let's think about how we can split up this 4a squared. Now the 9 is fairly easy. It's going to be 3 and 3. But the 4a squared, well, I know that the a squared is a and a. How can I break up the 4? The 4 gets broken up into 2 and 2. Now notice I put 2a and a 2a. The reason why is I want to divide them up evenly. I want a number with a variable anytime I have this type of situation. Therefore, when I actually factor it, it's going to become 2a minus 3 and 2a plus 3. Notice I have my 2a's and 2a, my 3 and my 3, and then one negative and one positive. So we have it factored out to where we have the difference of the squares. You just have to remember to separate out the number and the variable and put a number with each variable. Let's try another one similar to this, and that's going to be 25y squared minus 16x squared. Okay, I've got variables on both of them. I've got numbers on both of them, and I want to factor this. There's not a number that will go into 25 and a 16, and they don't both have the same variable, so there's not a greatest common variable here. So I'm going to factor the difference of the squares. Well, for the 25y squared, breaking down 25, that is 5 and 5, and breaking down the y, that's y and y. The 16 is 4 and 4, and they're each going to have an x with them. So whenever I actually factor this, I'm going to bring a 5y to the first blank of each parentheses, and I'm going to bring the 4x to the second blank of each parentheses, and I'll have 1 minus and 1 positive. 1 negative, 1 positive. So you're literally breaking up the variables so that they're evenly spaced between the two numbers. And notice that these are the exact same number and variable, exact same number and variable. This is if I have the difference of squares. It changes a little bit whenever I have cubes. When I have cubes, it will not matter if I have a difference or a sum. I'll break them up the exact same way. For example, if I have x to the third plus 27. Well, x to the third is easy to break up. That's 3 x's. Now then 27, think about how I can break that up into the same number. Well, 27 is 9 times 3, and 9 is 3 times 3. So 27 is 3 times 3 times 3. So I have a cube plus a cube. What's going to happen whenever I break up a cube plus a cube or a cube minus a cube is I'm going to have the first set of parentheses with 2 blanks, and the second set of parentheses is actually going to have 3 blanks. This is where we differ between the squares and the cubes. Squares are going to have 2 blanks and 2 blanks. Cubes are going to have 2 blanks and 3 blanks. This is what I like to call the football play, and you'll see why after I finish what happens. So this x is going to come to the first blank. Just like in the previous difference of squares, for the sum and difference of cubes, the first term is going to be broken up and put into the first blanks. So I have an x, and then these two will get multiplied back together. X times x gives me x squared, and it's going to go in the first blank here. Just like in the difference of squares, the first term went in the first blanks. The last term is going to do the exact same thing, except it's going to go in the last blanks. So this number here is going to go in the last blank here, and these two will be multiplied back together and go in the last blank here. So it's first blank, last blank, last blank. Notice that this is squared and this is squared. These are singles. Now then, this middle term here, that's always one that we're never sure because we don't have anything left up here to separate out. What happens to this middle term is it is the two terms of your first parentheses multiplied together. They go in your middle term here. So that's 3x. Okay, so these two get multiplied back together and they go in your middle term here. Now for the signs. And the signs are going to be the same based off of your original sign here. And what happens is the first sign is the same as you start. So whatever sign you start with, that's the sign that you're going to put in your first parentheses. Your next sign here is going to be the opposite as what you start with. So if you start with a positive here, you're going to put a negative here. If you start with a negative here, you're going to put a positive here. Key here is these two signs are going to be the opposites. This one's always going to be what you start with. Your last sign that goes here is probably your easiest. It is always positive. Does not matter what you start with. This sign is always going to be positive. So x to the third plus 27 factored out is actually going to be x plus 3 times x squared minus 3x plus 9. This is its factored form. And the reason why I tend to call it the football play is because you've got your x's, you've got them circled, and you've got lines going everywhere. If you've ever seen football plays, you know what I'm talking about. So let's try another example. Let's look if I have 27 x to the third minus 8y to the third. First thing I'm still going to do is look and see, is there a greatest common factor among all the terms? Well, no, there's not a number that I can factor out of 27 and 8, and they do not have the same variable, therefore there's not a greatest common factor. So then I'm going to look and say, okay, my variables have squares, cubes. Are they even or are they odd exponents? These are odd exponents, so they're cubes. And so then I'm going to say, okay, how can I break 27 up? 27 can be broken up into 3, 3, and 3. And then I have an x, and an x with it. Then 8 can be broken up into 2's, and each of those have a y with it. So whenever I factor, again, the first parentheses is going to have 2 blanks. Second parentheses is going to have 3 blanks. And I'm going to take my 3x and drop it into the first blank. I'm going to take my other two 3x's, multiply them back together. So 3 times 3 gives me 9, and x times x gives me x squared. So that gives me 9x squared. Again, they go into the first blank. First blank, because they're from the first term. Then the 2y, is going to come here. So I'm going to have 2y. My other 2y's are going to get multiplied back together. So 2 times 2 is 4. Y times y is y squared. And they're going to go in the last blank. So last blank, last blank. Then it comes time for my middle blank here. And I'm going to multiply these two terms of my first set of parentheses, 3x and 2y. So 3x times 2y will give me 6xy, which will go in my middle blank here. Then I start looking at my signs. I started with a subtraction sign. So my first sign is always the same as what I start with. My second sign is the opposite of what I start with. So if I started with a subtraction, this one's going to become an addition. And then my last sign, again, is the easiest. It's always positive. So I have 3x minus 2y times 9x squared plus 6xy plus 4y squared. That would be my final factored form of what I started with. And you just have to be careful, making sure that you break it up into the exact same numbers and variables here. Exact same number and variable. And then start putting them in the first and last blank, first and last blank. So what I would like for you to do is I want you to try some of the factoring binomials, and then let me know if you have any questions.